Welcome to Mrs. Riley's Maths videos. This is the first in a series of videos about probability and counting, recorded really for Junior Cert students, but anybody could watch it who's trying to understand this idea of the fundamental principle of counting, or as you might put it a different way, how many different ways can. Okay, so this is looking at what happens when we have lots of different options for an experiment or an event. In other words, lots of different things going on, and there's choices for each one, and we're trying to decide, well, how many different ways could that event happen? How many different ways could we have that meal? How many different ways could we arrange those books? How many different ways could that happen? Okay, so this is called the fundamental principle of counting, and I'll explain what that is in a minute, but we'll just start off by looking at an example. Okay, so you're busy at school, but you have a free afternoon for the first time in ages, and you're trying to decide what to do. The options, they're a bit restricted at the minute, but the options for you are, well, you could have a snack and do something relaxing. That would be good, wouldn't it, for a free afternoon? Have something nice to eat and do something relaxing. So you look in your house and you find that there's three options for snacks in your house. One is popcorn, one is hot chocolate, and one is an apple. And for things to do, well, four of the things you like to do are that you like to go on the Xbox or the PS5, you like to watch TV, you like to walk your dog, and you also like to read a book. So those are the four options open to you. So how many different ways could you spend your afternoon, or can you spend your afternoon? So let's think this through. So one thing that we have to learn to do in the fundamental principle of counting and in probability is what's called a systematic listing. What that means is that I'm going to write down all the different ways I could spend my afternoon, but I'm going to do it in a way that makes sure I cover them all and that I'm not left with any not covered. Okay, so what I'm going to do is I'm going to think about the snacks first of all. I could have popcorn for my snack. Okay, if I have popcorn for my snack, I could either spend time on the Xbox, or I could have popcorn for my snack and I could spend time watching TV, or I could have popcorn for my snack and then I could walk the dog, or I could have popcorn for my snack and read a book. Those are the four options: popcorn, Xbox, popcorn, TV, popcorn, walk, and popcorn, read. Now you'll notice that's quite a lot of writing, so what I might do is actually I might call popcorn P, hot chocolate HC, and eating an apple A, and I might call this just Xbox, TV, W for walk the dog, and R for read the book. So what this would look like then would be popcorn Xbox, popcorn TV, popcorn walk, and popcorn read. So there's four different options that involve popcorn as my snack. Now, but maybe I decide that I don't actually want popcorn, I want hot chocolate. So if I have hot chocolate, I could still play on the Xbox, or I could have hot chocolate and watch TV, I could have hot chocolate and walk the dog, or I could have hot chocolate and read a book. Hot chocolate Xbox, hot chocolate TV, hot chocolate walk, and hot chocolate read. Hopefully you can see where this is going. So there's another four options there with having hot chocolate. And then there's also, I could have an apple, which would be nice and refreshing, and watch and have play on the Xbox. I could have an apple and watch TV. I could have an apple and walk the dog, and I could have an apple and read my book. Okay, so I think that's all the options. That's all the snacks with each of the activities. All the snacks with each of the activities. So if I look here, I have four where there's popcorn. I have four where there is hot chocolate, and I have four where there is an apple. And if I add all those up, you can see I have 4, and 4 is 8, and 4 is 12. So I have 12 possible ways to spend my afternoon. Okay, now when we list all these ways, you can see I've listed them in a systematic way. I used a system which was to list the snack and then the activity. That's a systematic way. All these different ways, the 12 possible ways, is called the sample space. The sample space for choosing what I'm going to do for the afternoon. Those are all the ways that I could spend the afternoon. So we have a few different words here. We have systematic listing, which is a way of doing my lists, and there's other ways of doing that we'll look at later. A sample space refers to all the different outcomes, all the different ways, or outcomes. That's another thing. Okay, an outcome is what happens when we have an event. When you roll a dice and you get a 5, that's an outcome. When you toss a coin and you get a head or a tail, that's an outcome. Now, let's see, maybe our fundamental principle of counting will help us to work this out a quicker way. So say I didn't have to list. So say I didn't need to list all the outcomes. Okay, say for instance there were 10 snacks and there were 15 different activities. Whoa, I can see that that would be a really long list of things to do, and maybe I don't want to have to do that. So the fundamental principle of counting helps us with that. And what the fundamental principle of counting says, I'm going to write it here. Fundamental principle of counting, which sounds a very wordy way of saying, it says this: if one event or activity thing that we do has, now it says M, and I'll stick with M for the minute, but I'll tell you my alternative in a minute, has 1 outcomes, and a second event has N outcomes, then the total number of possible outcomes is M times N. Now, you have to admit, whoever chose M and N to do this is really not very helpful. So what I'm going to change here is just, I'm going to say W and T. And I'm going to say if one event has W outcomes and a second event has T outcomes, then the total number of possible outcomes is W multiplied by T. So if we go back to my example up here, what does that mean? If you noticed, for my snacks, the first example, I had 3 snacks and I had 4 activities. And the fundamental principle of counting says, instead of listing all of these, which I might have to do anyway, but if I didn't, I can find out that the number of possible outcomes is 3 times 4, which is 12. And in fact, if it did increase to 10 snacks and 15 activities, the number of outcomes that I would have had to list would be 10 by 15, which is 150 outcomes. Okay, let's look at a couple examples over here. Yoda just took a spin there. So, say you went out for a meal and you go to one of your favorite restaurants, and you know that you're going to have a starter and a main course and a dessert because it's your birthday, and you always have a nice big meal for your birthday. And on the menu there's garlic bread and chicken wings. On the for the main course there's pizza and fish and chips and salad, and for dessert there's ice cream and there's brownie. How many different ways could you order your meal? How many different possible meals are there to order? Well, you'll know that the fundamental principle of counting says that there's 2 starters, there's 3 mains, and there's 2 desserts. So 2 times 3 times 2, which is 12 different meals. Now, we might need to list those. So how would we list them? And I'm going to show you something that you may not need so much this year, but is very useful. It's called a tree diagram. And a tree diagram says, what we'll do is we'll take one of the starters. So we have starter, and then we have the main, and then we have the dessert. And this is another way of listing these possible meals systematically. So for starter, we have garlic bread. Now, with our garlic bread, which we're going to call GB, and we'll just write that up here. Okay. With our garlic bread, we could have a pizza. I'm just going to write them all once here. And with our garlic bread, we could have fish and chips. Or with our garlic bread, we could have salad. Isn't that right? Or we could have chicken wings and pizza. or chicken wings and fish and chips, or chicken wings and salad. Okay, does that make sense to you? Now, having had garlic bread and pizza, we can now choose between ice cream or a brownie. And what you can see here is that we've now got two different options. We've got garlic bread, pizza and ice cream, and garlic bread, fish and chips and ice cream. And actually I didn't do that one yet, did I? Ice cream and brownie, ice cream and brownie. So let's go through that again. Garlic bread, pizza and ice cream. Garlic bread, pizza and brownie. Garlic bread, pizza and ice cream. Garlic bread, pizza and brownie. Garlic bread, fish and chips and ice cream. Garlic bread, fish and chips and brownie. Garlic bread, fish and chips and brownie. Garlic bread, salad and ice cream. Garlic bread, salad and ice cream. Garlic bread, salad and brownie. Garlic bread, salad and brownie. And that's all the options that we could have with garlic bread as a starter. Of course, there's an alternative to garlic bread as a starter, which is chicken wings. So we could have chicken wings and pizza and ice cream, or chicken wings and pizza, and following the pizza we could have a brownie. Or we could have chicken wings and then we could have fish and chips and then have ice cream, or we could have chicken wings, fish and chips and then a brownie. Or we could have chicken wings, a salad and ice cream, or chicken wings, a salad and a brownie. So let's list those. We've got chicken wings, pizza and ice cream, chicken wings, pizza and a brownie, or chicken wings, fish and chips and ice cream, or chicken wings, fish and chips and a brownie, or chicken wings, a salad and ice cream, or chicken wings, a salad and a brownie. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's my 12 possible outcomes. You can see how much easier it was to do the multiplication than to list them. This here is the sample space. Remember we said the sample space was all the outcomes. This is a systematic way of listing, systematic, using a tree diagram. I guess it looks a little bit like a tree with some branches, but hopefully it makes sense to you. Now, let's take one more example, and in this we're going to talk about a two-way table, which is another way of doing systematic listing. So, two-way table. In this case we're going to roll a dice and toss a coin. There's my dice and there's my coin. Now let's think about it. We want to know, if we roll a dice and toss a coin, how many different ways could that work out? So we're looking for this sample space. Okay, we haven't been asked to list them yet, but let's say it also says list all the possible outcomes. So using our fundamental principle of counting, we don't have to write this each time, but I'm just writing it down here so that you see it. Okay, using the fundamental principle of counting, when we roll a dice and toss a coin, okay, when we roll a dice, how many outcomes are there? We could get 1, 2, 3, 4, 5 or 6. There's 6 possible outcomes. When we toss a coin, we can get the harp side, which we've said previously was a tail, but it doesn't really matter. We could get the harp side, or we could get the number side. There's 2. So the harp we're calling the tail, and the number we're calling the head. Okay, so for rolling a dice and tossing a coin, there's 6 options, 6 possible outcomes for a dice, and 2 possible outcomes for tossing a coin. So there's 12. 6 times 2 is 12 possible outcomes. Now, one way of listing those outcomes is to use what's called a two-way table. A two-way table is a table where we have two parts to it. Okay, now this is the 2 parts. What we're going to do is, along the top, we're going to put the outcomes for the coin. So this is the coin. And down the side, we're going to put the outcomes for the dice. So there's the dice. Now, what does that mean? Well, for instance, say I rolled the dice and I got a 1, and I tossed the coin and I got the bit with the number on it, which we're calling the head. That would be one option. So I could get a 1 on the dice and a H, a head, on the coin. But maybe I got a 1 on the dice, but in fact it flipped this way and I got a tail on the coin. Or maybe I got a 2 on the dice and a head, or a 2 on the dice and a tail. Or maybe I got a 3 on the dice and a head, or I got a 3 on the dice and a tail. And you can see I could have got a 4 and a head, or a 4 and a tail, or a 5 and a head, and a 5 and a tail, or a 6 and a head, and a 6 and a tail. Okay, you can see that that's all the possible outcomes I could have got. A 1 on the dice and a head on the coin, or 1 on the dice and a tail on the coin. Okay, so I might want to write down here H equals head and T equals tail. And that counts as my sample space of all the possible outcomes. Now, some of you may say, well, I suppose you could use a tree diagram for that. So let's just look what a tree diagram would look like. Let's do the dice. 1, 2, 3, 4, 5, 6. You could have a 1 and a head, a 1 and a tail, a 2 and a head, a 2 and a tail, a 3 and a head, a 3 and a tail, a 4 and a head, a 4 and a tail, a 5 and a head, a 5 and a tail, a 6 and a head, a 6 and a tail. And again, that's all the possible outcomes. Okay, hopefully that's been helpful, and we'll wait for the next video in a little while. Thanks, bye bye.